Hi everyone, today we're going to be doing homework 5A, in which it has two parts. Part 1 is derive in detail how the substitution S equals JW yields the long-term frequency response of a transfer function to a sinusoidal input. Part 2 is then explain why having a magnitude ratio at a phase angle of a negative 180 degrees results in an unstable closed-loop response. So what I'm going to be doing is I'm going to derive on the board part 1 with a lot of pre-written stuff, trying to get the ball rolling for the type of transfer function we're going to then be basically showing the response of. And then also on the board, I'm going to explain part 2. Thank you, and we will be right back.
Hi everyone, so what happened is I actually lost sound for all this part of the video, so now we're going to be doing a voiceover and hopefully it actually makes sense. So what we have here is basically writing our function or writing everything. And also showing that the Laplace function of a sine wt equals aw s squared plus w squared. So this function is we have our set point, or YSP, goes through our controller and then our process before it reaches y, and then once it goes back to the measurement, it responds or returns a sinusoidal function. So what I'm doing here is I'm circling this, and we're just going to label this as g, because g can be really big and really complex and can have a lot of roots. So we're just going to be writing this as g and not gc and gp to kind of simplify it for ourselves. And what I'm doing here is I'm writing the block step process. So we have g, which then goes into, we have our sinusoidal input, so a w s squared plus w squared goes into g, then goes, and when you're in a box, you just multiply it. And I know it's omega w. I think I said this in this video, but you can't hear it. But I really hate saying the word omega when I'm looking at a w, so I'm not going to say it. So now what I'm doing is we are now going to do a shortcut partial fraction decomposition to actually show what we want to, to basically get the transfer function. And what I believe happens here is I don't remember what part is what, and I do believe I actually go off the screen, so editing this was a pain. So what I'm saying is our first term, a over s plus bi, actually dies. With time, it cancels itself out. It goes kaput. So what that means is these next two terms are really the important ones, which I will show when we do derivations later in the video. But here, I am actually trying to remember which sign is positive and which sign is negative, so I do end up cutting the video, I believe. And I believe it was really hot in the room when I was doing it. I think it was 76 degrees, and I was wearing 3 layers of clothes, so I took off the first layer. So I eventually found out it was E plus Fj over S plus Jw plus E minus Fj over S minus Jw. And now what I'm doing is what's the best way to say this? I am extrapolating, or we're multiplying across these second terms into a big... Basically, we're just doing cross multiplication to get the same denominator, and then we're going to see what cancels. And j is actually what we're calling I. So I is the square root of -1, and that is what we're calling j. So j squared would be -1, which is how some of these terms end up canceling. Or how some of them shouldn't be, they don't look like they should be negative, but they are because there's a j in that term, or there's a j squared, which actually ends up changing said sign. And then C, showing what cancels. So when we end up actually getting 2es plus 2fw all over s squared plus w squared, which gives us in the term of cs plus d over s squared plus w squared, which is a sinusoidal term. So now what we're going to do is the next step is we're going to break it down into a Heaviside expansion. So I think what I'm saying is I'm going to erase, and then I'm going to be right back. I recorded this like a week ago, and I don't remember what I was saying, but yeah. I know I look like very animated while I'm saying it now. And so now I erased everything, and now we are going to write what is the Laplace transform of our cs plus d over s squared plus w squared, or the inverse Laplace, because we have it in Laplace terms, but when we take it out, to prove that it is a sinusoidal or a term like that, we end up getting c cosine wt plus d over w sine omega, sine wt. So now, again, we're dealing with the a what we did is we actually replaced the EF whatever with CS plus D over S squared plus W squared. And we're going to multiply across the S squared plus W squared from the G times AW term. And it's actually going to cancel the denominator for our CS plus D. And and then I'm saying something, obviously. What am I saying? Oh, and now we're doing our heavy side expansion where we're going to set S equal to JW, which means S squared is going to be negative W squared. So when you plug that into this term, you get negative W squared plus W squared. So it cancels. So we end up getting G equals times AW equals CJW plus D. So now we're going to divide AW across. We're writing this is G in terms of JW now. It is CJ over A plus D over AW. Again, I don't remember where the next cut is, and I think it'll be right here real soon because I look confused. Let's see, how much time do we have left? Oh, we're cruising through this. So I erased that. I rewrote it over on the left-hand side, and we actually changed the order. It's DAW plus C over A times J. And the reason is because we're going to turn these into poles. Our R is our real, and our I is imaginary because there's a J, and square root of -1 is an imaginary number. So we can rewrite it in terms of G equals R plus IJ. So now we can actually rewrite our original equation as IA cosine WT plus RA sine WT. And the reason we want to do this is because we can then set certain things up. Or actually, we can factor A out first. So if we factor A out, we get I cosine WT plus R sine WT. And now we are going to write that I over R equals tangent of theta, which means technically we can set up as inverse tangent of theta equals, or inverse tangent of I over R equals theta as well. That also sets us up as I equals, oh, where did I go? I equals M sine theta and R equals M cosine theta, which lets us do R squared plus I squared equals M squared cosine plus sine squared, which just gives us with M squared. So we actually, now we're plugging in this A and M, or I'm sorry, my R and I's for M cosine and M sine. So we end up getting sine theta cosine WT plus cosine of theta times sine WT. And I believe I forgot the trig expansion that we did doing this, in which I'm going to cut and then we're going to write rack. I was also really distracted while we were making this because across in the room, I could see people dancing. There was like a dancing class. Oh, I did not cut that very well, but it's okay. So the trig form, we have AM times sine WT plus theta. Let's see how much time we have left. We got 2 minutes. So that is essentially our long-term behavior. And the reason, this is just me showing the homework problem because I wrote them all down and I forgot that the part B and I didn't want to cut the video. So M is the magnitude ratio. So if M is greater than 1, it's unstable. It's basically the new over the old. If our M is greater than 1, we're just going to continue to spiral. And if we're, especially, the question is if when we are at theta, or a phase angle, I believe, whatever it's called, at 180 degrees, why is that unstable? Well, I'm drawing the graph of sine right now. And as you can see, at pi over 2 is what it's max, and then at 180, it's not. It's done at cycle, it's at 0. So anything under 180 after is going to be a negative answer. So it's just going to actually fudge with our controller and really why we are doing this. It's just turning our positive or our value into a negative change, which is something we don't want to do because that could really affect what we're looking at. And if we're having a negative value, which is wrong, and our new value is bigger than our old value, so M is greater than 1, it just means it's going to spiral like a blonde-haired woman who has just taken or stopped taking her antipsychotics. So I believe that is the end of homework 5A, and thank you for watching.